Hello students, hope you are doing good at home. We are moving towards the next topic of the chapter of group 16, 17, 18 and that is electronic configuration of elements of group 16, 17, 18. Here already we have discussed about the electronic configuration in 13, 14, 15. So just we are going to discuss about the general electronic configuration of all the three groups. First of all, as you can see that the group 16, yes, the group 16 elements are oxygen, sulfur, selenium, tellurium, polonium. So here you can see already I have written the electronic configuration. Yes, just we have to discuss for the general. You can see for the group 16. For the group 16 you can see we can write the NS2 NP4. Right students? So NS2 NP4. Here you can see when I am writing about this type of general electronic configuration for the whole group of 16. You can see over here, just look over here, you can see everywhere for the S you can see you can observe that it is 2, whereas for the P you can observe for the 4. So that it becomes what for the, if you know the atomic number, automatically just increase the what, you can increase the noble gases and at the same time just increase the number by one shell, automatically you can get the electronic configuration, provided you have studied in the 11th standard. You can see that additional for the D and or F for the last shells. So if it comes to the group 16, you can see for the NS2 NP4. For the group 17 it is going to be NS2 NP5, which is for our halogens, and whereas for the group 18 you can see it is going to complete the whole P block or the P group. Yes, that is going to be NS2 NP6. Right, as we have written for the 4, also we can write for the 5. Yes, it just increase the number of 9, 17, 35, 53 and 85. Automatically just P is being increased by the 5, and for the last you can see for the 18. So in the same way we can complete the electronic configuration of the group of elements of group 16, 17, 18. Next we will come to the topic of the atomic and physical properties of elements of group 16, 17, 18. So one by one we can see the whole topic related to it. First of all we are going to discuss about the atomic and ionic radii. Atomic and ionic radii for all the group 16, 17, 18 is going to be as such. As we move down the group, yes, as you can see, you can move down the group as the quantum shell. Yes, as the shell increases, the atomic size increases. As the number of shell increases, the atomic radii as well as the ionic radii is going to decreases down the group. Whereas when we are going to discuss for the period, you can observe from left to right, you can observe that the atomic radii is going to get decreases because the electron is going to enter in the same shell. As the electron is going to enter in the same shell, the effective nuclear charge increases, and because of that the atomic and ionic radii is going to get decreases from left to right for the group of 17, 18 and 16, 17 and 18. Yes students, so basically for the group, down the group, atomic and ionic radii increases, and for the period from left to right, the atomic and ionic radii decreases. Next we can see that is going to be the ionization enthalpy. When it comes to the ionization enthalpy, again we will see the atomic and ionic radii. As the atomic radii increases down the group, the number is increases, or as the number of shells are increasing, the atomic radius increases, automatically the ionization enthalpy is going to get decreased. The ionization enthalpy decreases because as the shells are being increasing, it is going to lose the effective nuclear charge, and automatically to remove an electron is going to be more easier. So when it comes to the ionization enthalpy, you can observe that the ionization enthalpy decreases down the group as the atomic radii increases, the ionization enthalpy decreases. So one more point I am going to let you know, I'm going to add over here, and that is what, when it comes to the ionization enthalpy, it is going to be low for the group 16. Yes, it is going to be low for the group 16 compared to the group 15. The reason behind it of the group 15 is what, that the p block contains what, it contains the 3 orbital. As it contains the 3 orbital, and in 15 you can see it includes the half-filled p orbitals. As it completes the half-filled p orbital, stable half-filled p orbital, automatically it is going to have the more ionization enthalpy, and when it comes to the 16 you can see that it is going to be less compared to the 15 one. Yes students, I believe you must have understood what I am trying to say. When it comes to the 16, ionization enthalpy is going to be, the value of ionization enthalpy is going to be less or low compared to 15, because the 15 have already completed the stable half-filled configuration, and because of that they are going to have the higher ionization enthalpy, whereas the 16 is going to have the low ionization enthalpy. But as you can see, as they move down the group, automatically the value of ionization enthalpy is going to get decreases, because atomic radii increases. So the next thing which we are going to discuss about the electronegativity. When it comes to the electronegativity, here we are going to discuss the important point related to it. Here you can observe the group 16. The group 16 contain the elements oxygen, sulfur, selenium, tellurium, polonium, and out of that the oxygen is the most electronegative. Yes, and you can observe when it comes to the group 17, the fluorine is going to be the most electronegative element of the whole periodic table. So these two important points we have to discuss when it comes to the electronegativity, and also the thing is going to be the same. As we move down the group, atomic radius increases, yes, but the electronegativity decreases. So the 2 points important we have discussed. The point number 1 was the electronegativity decreases down the group, and the second important point was the group 16 contain a single atom, it contains an element oxygen, which is the most electronegative element of the whole group, whereas for the group 17, fluorine is going to be the most electronegative element for the whole periodic table, right? And when it comes to the 18, we are well acquainted with the 18, because as it is the noble gas, it does not contain any kind of electronegativity, because it contains a complete stable electronic configuration, and automatically as it is the noble gas, it does not need any kind of electronegativity. Okay, so we'll move towards another point, and that is going to be the electron gain enthalpy. When it comes to the electron gain enthalpy, again we are going to see the same thing regarding to the electron gain enthalpy as we move down the group. Yes, as we move down the group, you can observe that it is going to show the low electron gain enthalpy, as it is going to show the low electron gain enthalpy from top to bottom. Yes, also we are going to discuss 2 more important points over here. Yes, point number 1 that we have already discussed, that it is going to show the low electron gain enthalpy. The point number 2 is what? That the value for the oxygen is going to be the less of the electron gain enthalpy compared to the sulfur. Yes, the point is the value for the electron gain enthalpy for oxygen is going to be low compared to sulfur. The reason behind this is what? As the sulfur is having, the oxygen is having the small atomic size, and because of that, the value for the electron gain enthalpy is going to be low for the oxygen and high for the sulfur. Yes, the concept is as such. The electron gain enthalpy for oxygen is going to be low because it is having the small atomic size, whereas the sulfur is going to have the higher electron gain enthalpy. So here we have discussed about the concept of an electron gain enthalpy. In the same way, we can consider for the 17 group as well. The same thing we have to discuss. Yes. Also, in the same way, you can observe for the fluorine and chlorine in the fluctuation. So when you are going to come to know about the whole topic, automatically you can confront for the 17 as well and very easily. So in this manner we have completed the topic of electronic configuration, and also we have completed the atomic and physical properties of the element of group 16, 17, 18 by the atomic and ionic radar, ionization enthalpy, electronegativity and electron gain enthalpy. Yes, I believe you must have understood the whole concept. In the next topic, in the next video we are going to discuss about the next